stirring preps. And
Biodynamic preps.
Then is biodynamic agriculture. Try to get your head around this. Bio has to do with life, and dynamics has to do with processes or activities. So we're not talking about anything that's not in motion, that's not going through some sort of activity or process. So biodynamics is farming with life processes. Now the life processes are what engage the materials. So the materials without the processes, they're not doing anything at all. So in our conventional agriculture, where we're talking about phosphorus or potassium or calcium or whatever, we're not talking about the processes at all. We're not talking about anything that's alive or that is doing anything. When we talk about chlorophyll, we come about as close as anything in conventional agriculture to talk about processes, because when we talk about chlorophyll, we're usually talking about photosynthesis, and the photosynthesis is a process, whereas the chlorophyll is the material side of that process. And the actual process involves more than the chlorophyll. The chlorophyll is a magnesium atom with 4 protein chains attached to it. And it's capable of catching photons and producing free electrons. And the process actually involves adenosine diphosphate, which is circulated through the plant's transport system to the chloroplast, where it picks up an electron and becomes adenosine triphosphate and circulates back into the rib where the carbon dioxide and the water are, and the energy is imparted to the carbon dioxide and water to make a carbohydrate, a sugar, and free oxygen. And so the plant gives off the oxygen and then transports the sugar to some place that the sugar is useful in the plant. And the adenosine triphosphate, once it's given off its electron, it becomes adenosine diphosphate again and goes back to the chloroplast. And the efficiency of the photosynthesis is determined by the speed of the transport system. So in that process of photosynthesis, the transport system is the basis of how efficient it is, because if it's got a really speedy transport system, then it can make a lot more sugar from the amount of sunlight that's hitting it at any given moment, because it can use more of it. And so where you've got a grass, like this is a grass, okay? You don't mind me breaking that off? If you look at the transport system on this grass, it's all straight line. And that's a silica gesture, that it acts like a hair, a needle, you know. You can see here, I split it off by accident. And you can see the transport system, how linear it is. And that's very fast. A bullet train is going to be able to go real fast because the track is straight. If you've got a train that winds around like that, you know, in order to climb over the Pecos Mountain, then it's going to be a slow train. So all of your, like, broadleafs, let me look for a broadleaf, and this is a broadleaf, and you can see the transport system's got all kinds of little twists and bends and junctures and so on and so forth, and it's a slow transport system. So this plant is nowhere near as efficient in making sugar as this one. This one is going to catch a lot more carbon and turn it into sugar, carbohydrates, cellulose. You know, cellulose is polymer glucose. So that's that process of photosynthesis. So grasses are great at making sugars, but they're not very good at certain other things. See, they're dependent on the silicon in that transport system. But silicon is like with sand. And sand, which is silica, is pretty close to being inert. You know, your sand just lets everything pass it by, and it just, you water it, and it just goes right on down through the sand. And the sand doesn't hang on to much of it at all. And the sand only releases silica off of the surface of its particles. It doesn't dissolve. So if you, now here in New Mexico, we have a lot of lime in our soils. And lime is the calcium, magnesium, potassium complex. All of those metallic ions in the soil. And that will include iron and